Hello there, my name is Maher Haddad. Today I'm going to show you how to configure basic BGP routing in this scenario. Let's go to the lab scenario, and we can read here. You work as network engineer in a company and you have a network under BGP Autonomous System 2. So this is our network over here. Your company has purchased another company which has BGP Autonomous System 1 and needs to be merged with your company's network. So this one over here needs to be merged with this one. The first task we have is to configure R1 and R2 to form BGP neighborship between loopbacks as you have redundant link. So we can see here that we have two serial interface on router 2 connected to two serial interface on router 1. So we have to form the BGP relationship or neighborship between loopbacks. In this way, if in case one serial interface goes down, the second serial interface will take place. Let's read then we have to advertise loopback 1 and loopback 2 of R1 into BGP using network command. So loopback 1 and 2 should be advertised using network command. And then loopback 3 using redistribution command. Then this one should be advertised to BGP using redistribution command. And then we have to ensure that R2 can ping those loopback and they appear into its routing table. So we have to be able then from router 2 to ping those loopback interface. Okay, let's go to the lab. So this is the graph over here to know what we have to do. So first we have to form neighborship between router 1 and router 2 with the loopback interface. For this reason, we have to create a static route from router 1 to be able to reach the loopback of router 2. And I will create two static routes, 192.168.21. One goes for this serial and one goes from that serial. So here I say IP route to reach 2.2.2.0 255.255.255.0 go to 192.168.12.2. Then I will create another one to go to 21.2 and I will give it a distance metric. I will make it, let's say, 20 or 15. Then it takes the first one and this one will be alternative. And then on router 2 I have to do the same thing. IP route to reach 1.1.1.0 255.255.255.0 go to 192.168.12.1 and then 192.21.1 and 15. Now if I do from here router 2 ping 1.1.1.1, it should be okay. From router 1 if I do ping 2.2.2.2, it should be okay. So as we are on router 1, let's configure BGP. And then I have to say router BGP 1 no auto summary. It's a very important comment. And then here I have to say neighbor 2.2.2.2. This is the neighbor, and then the command which comes after should be remote autonomous system 2. And then I have to say neighbor 2.2.2.2 and update source loopback 0. I will do the same on router 2. Router BGP 2 no auto summary neighbor 1.1.1.1 remote autonomous system 1, then neighbor 1.1.1.1 update source loopback 0. Now, in this case, if I do show IP BGP, I have nothing. Show IP BGP summary, then there is neighborship, but it's idle. Now, if I advertise now the loopback here, it should not work, and the reason is because the neighborship between two different autonomous systems should be directly connected. But here we are doing neighborship with loopback 1.1, which is not directly connected to router 2, and then for this reason it will not form. But just to show you that, I will the second step here, they're saying advertise L1 and L2 of router 1 into BGP using network command, and so I will advertise loopback L1 and L2 into BGP to show you that this will not be shown into router 2. So here I will say router BGP 1 network 10.0.1.0, then mask 255.255.255.0, then L1 and L2. Okay, so as you can see here, show IP BGP is not yet advertised into router 2, and BGP is basically very slow, but this is not the reason why these networks has not been advertised. The problem here is that router 2 is not directly connected to loopback 0 of router 1, and router 1 is not directly connected to loopback 0 of router 2. Then there is one more comment we have to say here. On router 1 I have to say neighbor 2.2.2.2, and then the comment which I need to put is Ebp Multi-Hop, and it's 2, so I need 2 hop to reach this 2.2.2.2. That's on router 1, and then I will do the same on router 2. Router BGP 2 neighbor 1.1.1.1 Ebp Multi-Hop 2. So let's wait a little bit, and then the neighborship should be formed. As you know, BGP is a little bit slow, but I think that it should be okay. Now you can see here that neighbor is up. So always when you have eBGP, you should use eBGP Multi-Hop command. So now if I go to router 2 again and I say show IP BGP summary, okay, that's okay. So I show IP BGP. Okay, now I can see 10.0.1.0 and 10.0.2.0. So if I ping them, 0.1.1 is okay, 10.0.2.1 is okay. All right. Now, so configure R1 and R2 neighborship with loopback is okay. Advertise L1 and L2 using network command, and then L3 using redistribution. So we advertised L1 and L2, then L3. We have to do it using redistribution. And to do that, I have first to create an access list and say permit 10.0.3.0.0.0.255. Then I create a route map. Let's call it redistribute, and then permit and sequence number 10, Then I say match IP address, which is the access list here, which is number 1. And I want to, this is all what I need to do. And then I go to router BGP 1 and I say redistribute connected, because loopback is connected. And then route map redistribute, and that's it. So now if I go to router 2 and I say show IP BGP, and sure, you can see here that network 10.0.3.0 is shown now. So if I ping it 10.0.3.1, it's okay. Now we have to ensure that everything is shown onto our routing table. As the next step, they say to show that everything is shown in the routing table, and here you can see that BGP is shown into our routing table. Now a small trick here, because the first task is finished, and then ensure that router 2 can ping those loopback and they appear into the routing table. So this we have checked and it's fine. Now I want just to tell you why we did the neighborship between loopbacks and not between serial interface. And the reason why is because if I do here on router 2, for example, let's show you, if I do trace route on router 2 10.0.1.1, for example, it will go to this IP, which is on serial, so it will get out from serial 0/0 to this serial 0/0 and then to this network. But there is another path. So let's shut down this interface serial 0/0, and I say shut down. Do you think that I will be able to reach this network again? Let's check. Trace route 10. So yeah, as you can see here, first it went to 12.1, but now it goes to 21.1. So let's bring back the serial interface up. No shut. Okay. Yeah, the second step. Okay, then this step is say step number 2. Shut down the serial interface serial 0/0. Is router 2 still able to ping the loopback on R1? If not, please solve the problem. Yes, it's able, because we have created the 2 IP route to router 1. Now R2, R3, R4 and R5 are configured with internal routing protocol OSPF. So over here all are configured with OSPF and they have neighborship with OSPF. However, router 5 should learn about BGP, should learn about BGP networks advertised on R1, sorry. So I mean router 5 is here, he should know all about all the loopback 1, 2, 3 which have been advertised to router 2. So for this reason, configure R2 and R5 to form BGP neighborship between loopback interfaces, so also between loopback, as router 5 has redundant path to router 2. So why again we want to configure between loopback is because router 5 can take this way and he can take this way, so it's better to configure this between loopback. Okay, so now one more thing to say here, that inside an iBGP, which is or let's say, yeah, in the same autonomous system, you can form neighborship with any router, even if there's no direct connectivity between these two routers. So now I go to router BGP 2, and I say neighbor 5.5.5.5 remote autonomous system 2 neighbor 5.5.5.5 update source loopback 0. Now if I go to router 5, router BGP 2 neighbor 2.2.2.2 remote autonomous system 2 and neighbor 2.2.2.2 update source loopback 0. So now the neighborship should be formed in a minute. As you can see here, it's now up. So IP BGP. So the neighborship is formed. So what's the second question here, they said? Okay. Once neighborship is formed between router 2 and router 5, ensure that router 5 can ping loopback on loopbacks on router 1 here should be, not router 5. If not, then solve the problem. So there's neighborship formed between router 2 and router 5, then they ask us that router 5 should be able to ping the loopback. So now if I go to router 5, I did show IP BGP, I can see that these routes, these networks are shown for router 5. But if I do show IP route, they are not there. And the reason why, so if I do again show IP BGP, the reason why that these routes are not there is because they are missing this, the greater sign here that should be shown here. So if I go to router 2, for example, and here I do show IP BGP, you can see that this one is shown, while for router 5 is not there. And this needs to be solved. And for this reason, we have first to check here that the next hop for router 5 is shown 1.1.1.1, but router 5 doesn't know 1.1.1.1. So for this reason, let's do the first step here. For this reason, the next hop here, we should make it 2.2.2.2. To do that, because of course router 5 can ping 2.2.2.2 because we are in OSPF area, but he cannot ping 1.1.1.1. Okay, to do that, I have to go to router 2 here. Inside router 2, I have to say router BGP 2 neighbor 5.5.5.5, and here I have to say self yeah, it's next hop self. Okay, so now if I go back to show IP BGP, so now router 5 is able to go to router 2. Then you can see here that router 2 is shown for as the next hop, and there are here the sign is shown here. So now if I do show IP route, so it's here. Now if I do ping 10.0.1.1, for example, it's unreachable. So let's check what's the problem. I do trace route 10.0.1.1. Okay, and we can see here that it's reaching the router 3 and router 4, then it's stopping. And the reason why this is happening is because router 3 and router 4, when router 5 send, he say to router 3, please send this to 10.0.1.1, 10.1.1. Then router 3 doesn't know about 10.0.1.1. Then it's stopping. Then router 5 send it here. Then it's, yeah, there's a problem over here. Then in this case, we have to redistribute this network inside OSPF. Then these routers, which are not running BGP, can know how to send the packet to this network. Or what we have to do, we have to configure, also we can configure BGP on our router 3 and router 4. So we have two options. What I will do, I will just redistribute BGP into OSPF, but this is not a good idea for always, because BGP could be very big routing table, and OSPF cannot hold this big routing table. So I will go to router 2 now, and what I will do over here, I will create an access list 10, and I will say permit 10.0.1.0, then permit 10.0.2.0, then permit 10.0.3.0. So these are the network of router 1. Then I will create a route map, and I will name it, for example, cursors, whatever. Permit 10. Then I will say match IP address access list number 10, and set metric to 50. Then I have to go to router OSPF 1, and here I have to say redistribute BGP 2. We are in BGP 2, subnets of course, and then with route map. And what was the route map we create? Cursors. And that's it. So now I have to go to router 3, show IP route, and we can see that these networks now are shown to router 3, and show IP route on router 4. Also they are shown in OSPF and router 4. Now let's try to do ping again. 10.0.1.1. Now before it was giving me unreachable, now it's timed out. So let's do trace route 10.0.1.1. See what's the problem. Okay, we can see here that it's sent it from this way and this way, then it reached router 2, but then the problem is now on router 2. Before it was only here, but now the problem is on router 2. So let's go to router 2 and check what is the problem. Show IP route. So router 2 is not able to send this to router 1. Yes, I think I know what's the problem. The problem now is that we have created a static route to this network only, but for the other networks we did not create a static route. So what I will do now on router 2, I will do show run. I will delete this static route which I have created. So I will say no this IP route, and no this, no this IP route, and now what I have to do, I will create an IP route, a default static route, 0.0.0.192.168.12.1 and another one, 21.1.15. And now let's try. Now it should work now. Ping 10.0.1.1. Okay, then I have to create also, there's a problem maybe also on router 1 here, that on router 1 also we said if we created an on router 1, if I do show IP route, also the static was to this 2.2.2.2. Then I will do the same here, show run include section IP route. No. Now I create IP route 0000 192.168.12.2 21.2. So router 1 did not know how to come back to router 5. So again, yes, now it is working. So now router 5 can ping these networks. So we can do 2.1. We can do ping to 3.1. Okay, it's working now. So ensure that router 5 can ping loopback on router 1, it's not 5. If not, then solve the problem. Then we solve the problem and now it can ping it. So one more thing to do here is that on router 5, if I do trace route 10.0.1.1, we can see that it's, yeah, so it's going this way and this way, and then it's going one of these ways. So what I have to do now, I will shut down the interface on router 5, let's say 0.0/0, and I will say shut down. So if we created the neighborship between BGP between this serial and this serial, then the neighborship will go down. But now if I do again trace route, you can see, I will do it again just because there is one line which has been shown from console logging. So you can see here that now from router 5 it goes to router 4 and then to router 2 and then the router 1. So because this one is down, then it took the other way. Okay, I will bring back the interface. So I hope you enjoyed this lab.